This section examines charging. The charging system provides electrical energy for all of the electrical components on the vehicle. The main parts of the charging system include the battery, the alternator, the voltage regulator, which is usually integral to the alternator, a charge warning or indicator light, and wiring that completes the circuits. The battery provides the electrical energy for starting. Then, once the engine is running, the alternator supplies all electrical components of the vehicle. It also charges the battery to replace the energy used to start the engine. The voltage regulator prevents overcharging.
The final step in a complete electrical systems check is to evaluate the charging system. While the VAT works fine for this test, I'm going to be using a multimeter and amp probe.
Begin by connecting the volt leads to the battery. Next, zero the amp probe using the manufacturer's recommended procedure. And then place the probe around the most easily accessible battery cable. Now, with all electrical accessories turned off, start the engine. Raise engine speed to approximately 2,000 RPM while observing charging system voltage. Under no load conditions, alternator output should be at least 14 volts. Now, load the electrical system by turning on the lights, high-speed blower, air conditioning compressor, and rear defogger if equipped. Under load, charging voltage shouldn't drop more than a half a volt. Next, adjust the meter to display current, and then increase engine speed back to about 2,000. As the meter indicates, the alternator on this vehicle is producing nearly 90% of its rated output.
If little or no output had been indicated, then a full field test would need to be performed. Let's watch this being done on a vehicle that has a charging system problem.
The alternator on this vehicle is designed with an A-type field circuit, which means that the voltage regulator grounds the field winding. An access hole at the rear of the unit is provided for full field testing. This hole accepts a guide bushing, which should be installed before inserting the ground probe. Once the integrity of the charging system wiring has been verified, the alternator harness connector can be reinstalled. Now, with the engine running, insert the ground probe into the access hole and ground the test lead. This allows full battery voltage to be applied to the field winding. As you can see, charging output increases significantly with the field winding grounded, which means that the alternator is okay. Therefore, the problem with this vehicle is a defective voltage regulator.
The internal components of an alternator, including the rotor, stator, and rectifier diodes, can all be checked using the ohm meter function of your multimeter. Let's take a look.
To check the continuity of the rotor's field winding, probe the slip rings with the test leads. Under this condition, the resistance reading should be no more than 2 to 3 ohms. Now move one of the test leads to the rotor shaft. Unless the rotor is shorted, the ohm meter will indicate infinite resistance. To check the stator for continuity, attach one of the test leads to any phase winding, while probing the other 2 windings with the opposite lead. On a good stator, the ohm meter will display close to 0 ohms each time. Now attach the black lead to the stator frame and probe one phase winding at a time with the other lead while observing the meter. As long as the stator isn't shorted, the meter will display infinite resistance continuously. Before checking the rectifier diodes, select the diode test position on the multimeter. Each good diode will generate a low ohm reading in one direction and a high reading with the test leads reversed.
If any of the diodes produce the same reading in both directions, the rectifier assembly will have to be replaced.